All right, so we're going to start by, I'm going to ask you if you would get some paper, loose leaf, so that you can write these questions down, because I think it's really important for you to write the questions down and take notes, because you're going to then be doing a Castle Learning assignment that's directly related to this, and you can use these notes to help you answer those Castle Learning questions. Okay. All right, so the name of the game here, if you look at the title of this assignment, it's called Complex Fractions. So this is a complex fraction. Basically, all a complex fraction is, for what we're going to be doing, is we have one fraction over another fraction. Now let's talk about this. Okay, notice I made it really dark. So again, you have a numerator of a fraction, and this is the denominator. Okay, so fraction over a fraction. Now, let's think about what this line also means. Doesn't when we have a fraction, doesn't that also mean division? So this is really 2/3 divided by 4/9. Okay, now I'm not always going to write it this way, but for the first question, I will. So if I were to rewrite this question, I could rewrite it as 2/3 divided by 4/9. Now you won't always see it written this way. A lot of times you'll see it written this way, and that's why I don't really write it this way. But for the first one, I think it's good. Now, do you remember there was a saying that you learned way back when, keep, change, flip? It should kind of sound familiar. If you haven't, don't worry about it. So keep means keep the first fraction just as is. Change means we're going to take this division and we're going to change it to multiplication. And then flip means take your second fraction and simply take its reciprocal or flip it. Okay, so again, keep, change, flip basically means that if we have a division problem, we can change it to multiplication as long as we take the reciprocal or flip that second fraction. Okay, so then hopefully you remember that when we have fractions like this, we can cancel to make our lives a little bit easier. So in other words, I notice here that 2 and 4 have a common factor of 2. Well, 2 goes into 2 once, and 2 goes into 4 twice. And then I also see 3 and 9, they have a common factor. 3 goes into 3 once, and 3 goes into 9 3 times. And then remember, when we are multiplying fractions, we always multiply across. So numerator times numerator, which is going to give me 3. And then lastly, we're going to multiply denominator by denominator, which is going to give me 2. And there's your answer, 3/2. All right, so let's look at the second question. So the second question is also a complex fraction because we have a fraction divided by another fraction. Okay, so now let's remember the saying from the last question, which is keep, change, flip. Okay, so let's go up to this question. So remember the rule is we keep the first fraction, and the first fraction is 3/x. Remember that, this means division, so we're doing 3/x divided by 2/3x. So we're going to change this division, right, because this says change. We're going to change that division to multiplication. And then lastly, we are going to flip this bottom fraction. So instead of writing 2/3x, we're going to write 3x over 2. And then lastly, we're just going to try to cancel out any common factors. Now remember, when we have common factors, any numerator and any denominator is what we can cancel. So I see an x in the denominator here, and I see an x in the numerator here, so I can cancel both of those guys. Now, think about this. Can I cancel this 3 with this 3? And I hope you're saying no, because both of these 3's are in the numerator. And I just finished saying that you can only cancel numerators with denominators. So now remember in the last question, when we have fractions and we're multiplying, we multiply going across. Okay, so in the numerator, we're going to have 3 times 3, which is 9. And in the denominator, we just canceled out this x with this x. So really all I have left here is a 1. So I'm doing 1 times 2, which is 2. And there's your answer. All right, so I wrote the magic saying down at the bottom, keep, change, flip. And again, please make sure you're taking notes because you're going to be doing CASEL learning assignment and these notes will be really helpful. So let's look up at the top here. Again, we have complex fraction because we have a fraction divided by another fraction. So when we say keep, remember that means keep the first fraction. So I'm going to write 25 minus x squared, and I'm going to keep it just as is. X plus 5, that quantity squared. Change means change the division to multiplication. Flip means take the second fraction, in this case, the fraction in the denominator here, and we're going to flip it. I'm going to put x squared plus 2x minus 15 in the numerator, and x minus 3 in the denominator. Okay, well, this one's a little bit trickier than the first and the second one because we have some things we need to do here. So hopefully you're noticing that this is dots. It's in reverse because we're used to having the variable portion first, but we can still do this. So why don't we tackle that first? I am going to make myself kind of like a blank set of fractions here. So 25 minus x squared, that's going to become 5 minus x and 5 plus x. Remember the 5 has to come first because the 25 comes first. All right, let's tackle this. If we have a quantity and it's squared, doesn't that mean that we can write that quantity twice? I'm going to change that denominator then to x plus 5 times x plus 5. All I'm doing is just writing it twice. No factoring, nothing fancy, done. Let's look at the second fraction now. Now the second fraction, we have a trinomial here. So we want to think about what adds to 2 and multiplies to negative 15. So what adds to 2 and multiplies to negative 15? All right, we're going to have 2 sets of parentheses. X goes in the beginning of both of them. Well, I know 5 and 3 multiply to 15. And I need to add to get a positive 2, so that must mean the 5 is positive and the 3 is negative. Make that look like a positive. And then let's just copy down the denominator there because there's nothing we can do there. Okay, let's look at what we have here. So this fraction right here really is equivalent to this fraction, or this problem I should say, up here. It's just factored out. Now remember, the name of the game is when you have a fraction multiplied by another fraction, you can cancel like terms as long as those like terms are in the, one is in the numerator and one is in the denominator. So let's see what we have here. All right, well, I know that x plus 5 and 5 plus x are the same thing. That's like 2 plus 3 and 3 plus 2. Any way you look at it, you're still getting 5. And then I also see, if I go diagonally here, this x plus 5 and this x plus 5 are like terms. This one's in the numerator, this one's in the denominator. So I can still cancel those. Gone, gone. I notice that I've got another set of like terms. I've got my x minus 3's here. This one's in the numerator, this one's in the denominator. So we're good to go, and we can cancel those. Gone, gone. All right, now let's remember that when we're multiplying fractions, we multiply across. Well, look at the only factor that we have left here on the left side is 5 minus x. And the only thing we have left here, when these guys cancel out, remember that we're always going to have a 1 here. We just don't tend to write it. So this is really 5 minus x times 1, which is just 5 minus x. And then in the denominator, let's just quickly check, but hopefully you realize there's nothing left here. So we understand that that's going to be a 1. I don't have to put this over 1. I can, but it's not necessary. So I'm just going to write my answer like that. Done. All right, so the last one. Now, if you look at this one's written a little bit differently because it's written horizontally, but I think in some ways this one's a little bit easier because you don't have it written as a fraction over a fraction or a fraction divided by a fraction. You have it written as a fraction side by side divided by another fraction. Well, we can still apply the same rule that we've been applying, that keep, change, flip. So in other words, let's take the first fraction. Let's keep it. Remember, change division to multiplication. And remember that we are going to flip that last fraction. So x squared minus 16 is going to become the numerator, and 5x is going to become the denominator. All right, so there's our problem. That's what we need to work out. I hope that you see something here, and we can factor this by using dots. So I'm going to just keep working my way down like this. So this fraction's good to go. There's no factoring that needs to be done, so I'm just going to leave it as is. But I've got dots there, so that's going to make that x minus 4 and x plus 4 all over 5x. All right, now remember what I've been saying with the other three problems. If we want to simplify, we can always cancel like terms as long as they are in, or I should say one is in the numerator and one is in the denominator. So I see here I have an x plus 4, and I see here I have an x plus 4. All right, so let's cancel those guys out. X plus 4, x plus 4. Now the other thing that I also see that I have is I have an x here, and I have a 5x here. Okay, so I can cancel the x here and the x here. Now that keeps the 5. Keep in mind that this is really 5 times x. So I can cancel this x with this x, but we would keep the number in front. All right, now lastly, when we're multiplying fractions, remember we multiply across. So I'm going to multiply this way, and I'm going to multiply this way. Now remember, over here, I just want to take a look for a moment here. When everything's canceled out, remember this just is a 1 over 1. Okay, so when I'm multiplying across, the only thing I really have left is that factor of x minus 4 in the numerator. So x minus 4 in the numerator. And then in the denominator, well, I've just got a 1 here, and here I have a 5. And 1 times 5 is 5. And there's your answer.